How do we name ionic compounds? How do we name acids? Let's find out. Before we get into naming ionic compounds, let's start with naming individual ions. Ions are atoms or molecules that have a positive or negative charge. Metal atoms will lose electrons to become cations, ions with a positive charge. And nonmetals will gain electrons to become anions with a negative charge. Cations are named with the same name as their original element but with an ion at the end. So, when sodium becomes a cation, it has a +1 charge and is known as a sodium ion. And note, we don't write ones in chemistry, so we just write Na+. Anions are named by replacing the original atom's ending with "ide" instead. So when chlorine becomes an anion with a -1 charge, it is known as a chloride ion. When ionic compounds form, a cation and an anion stick together and balance out each other's charge. We write the cation first and then the anion, and we name them the same way. If sodium and chloride ions come together, a +1 and a -1 cancel out, and they form NaCl, or sodium chloride. These rules apply regardless of charge, because many elements only form one charge, so their charges don't need to be stated. Consider if instead of sodium we used calcium. Calcium forms a cation with a +2 charge. But it's a cation, so we still just use the element name plus ion and call it a calcium ion. When it forms an ionic compound with a chloride ion, now we need 2 chloride ions to balance out the +2 on the calcium ion, and we get CaCl2 for the formula. Naming it is still cation plus anion, so the compound CaCl2 is known as calcium chloride. Common ions with one charge that we should be aware of include the group 1 metals, which all form +1 charges like sodium and potassium, the group 2 metals, which all form +2 charges like calcium and lithium, group 7 or group 17 elements, the halogens, which will form -1 charges like our chloride or fluoride ion. And some other common nonmetal anions we should know are the oxide ion, O2-, the sulfide ion, S2-, and the nitride ion, N3-. But what about the rest of the elements? Transition metals can form multiple charges when they become ions. So how do we name them in compounds? We just add the charge to the name with Roman numerals. For example, lead can form a cation with either a +2 or a +4 charge. That is, it can form the lead-2 or lead-4 ions. Once we know that, naming a compound is the same. We just stick the cation in front of the anion. For example, PbCl2 is lead-2 chloride. PbCl4 is lead-4 chloride. What if we throw polyatomic ions into the mix? We just use their names unchanged. Nitrate, NO3-, will combine with sodium to form sodium nitrate. Sulfate, SO4-2-, will combine with copper-2 to form copper-2 sulfate. And ammonium, NH4+, will combine with chloride ions to form ammonium chloride. Many acids are ionic, so let's take a look at how to name those. For binary acids, acids with 2 components, consider HCl, hydrochloric acid. Our cation is hydrogen, so it comes first, and in acids we call that hydro. Our anion is chlorine, but instead of calling it chloride, we change the ending to "ic" and get chloric. Then we just add acid at the end, so we get hydrochloric acid. Our ionic acids will always have hydrogen, so the only part that's going to change is the anion. It will always be hydroanionic acid. So, HBr would be hydrobromic acid, and HS would be hydrosulfuric acid. Our polyatomic anions also form acids, particularly the oxoanions, the anions containing oxygen. Let's take a look at bromate, BrO3-. As an acid, it would have a hydrogen and be HBrO3. To name it, we would change the ate ending to an ic ending. So bromate forms bromic acid. And you can remember that because if you've ever eaten too much, you might say, "Ick, I ate too much." For the bromite ion, BrO2-, it would form HBrO2. Which would be named by changing the ite ending to us. So bromite ions form brom-us acid. And that's the only 2 rules. If we have BrO-, that's hypobromite, and its acid, HBrO, is still named just by changing the ite to us, giving us hypobromous acid. And perbromate, BrO4-, would eat too much and give us the ick for perbromic acid. And while polyatomic ion names mostly need to be memorized, if we look at this, we see that only the oxygens are changing. This means if you know your ate compound, ite will have 1 fewer oxygen, hypo will have 2 fewer oxygens, and per will have 1 additional oxygen. And this is the same for every polyatomic oxoanion. SO4-2- sulfate forms sulfuric acid, and ClO2- chlorite forms chlorous acid. But let's take a closer look at a polyprotic or multiple hydrogen acid like phosphoric acid. Phosphoric acid, H3PO4, can lose a hydrogen 1 at a time until it becomes the phosphate ion it's derived from. In between, instead of naming them like acids, we name them like ionic compounds. But because the charges aren't balanced, we have to indicate how many hydrogens there are with a Greek prefix. For example, H2PO4- would be dihydrogen phosphate, telling us there are still 2 hydrogens left. HPO4 2- only has one hydrogen left, so no prefix is needed and it's just hydrogen phosphate. Then, if these ions are in an ionic compound, we just name them as usual and put the cation we've added in front. For example, using potassium would give us potassium dihydrogen phosphate and potassium hydrogen phosphate. Because we know the charge of phosphate never changes and the prefix tells us how many hydrogens there are, we don't need to indicate how many potassiums there are. It will be however many is needed to balance the charge to 0. And that's it. That's how we name ionic compounds and acids.